Optilab, and we have Henry Hughes. Oh, sorry for the pronunciation. Okay, so we will see demo of Optilab.
Give him the mic.
Thank you for giving us this opportunity to demonstrate our second generation interrogator. Next slide, please. In the first slide, I just want to go over very quickly what we have as our first generation interrogator. Essentially, our features is very high power. We can go up to probably watts of power, but it's 20 milliwatt standard and go up to 200 milliwatt. Both units have different form factor, and the difference is that the slimmer unit 1U interrogator has a dynamic gain adjustment feature for the PD. So in a situation where you have a network that was aging structure or with varying losses, we will be able to dynamically adjust that. But other than that, it's the same. Next slide, please. Very quickly that we feature our advantages in our systems, that we have much higher power. We can easily go up to 200 milliwatt for a laser, and we have a typical range of 60 nanometer, and the sweeping rate is 10 hertz. This is a standard tunable laser architecture. Depending on the sweeping speed, we have a minimum of 30 dB dynamic range, and since we have a very high power, so we could really have some advantage there. Next slide, please. But the main thing that we're here really to present is essentially our next generation interrogator. The specs are essentially governed by our customers' requirement. This is not completely finished, and we'll get into that very quickly. But it's going from 10 hertz to 1 kHz on the scanning range. At the current state, it has 8 fiber channel, and it's a standalone embedded system that's very rugged. And due to that, we don't need a PC. We don't just Ethernet output, and we can provide many format of data. And the specification is, as of current, is for 8 channel, and we can go up to 32 channel without changing much of the electronics and optics. We can go up in a scan frequency currently at 5 MHz. That's what our demo is gonna show. And we can go up to 1 kHz in the very, very near future. The other specs are standard, 1 picometer, stability, accuracy. And currently that we can push to 65 nanometer. But there are other technologies that we are considering to see how we can extend that. So in terms of wavelength power, again, we could have a same optical design, can go high power. Okay. And where are we going with this interrogator? Essentially, it's really talking toward to a very specific aerospace market. We're looking into the entire hardware will be under 3 pump. That's not including the chassis and power supply. And it will be very ruggedized and will pass all of qualification required for the flight test. And we're looking at power consumption under 20 watt, and the housing that located on lower right corner, that's a mini ATR chassis, which is a very standard for aerospace mounting rack. Okay. And what this demo basically is that we basically just looking at the strength, and we basically take a pen and hit a strength sensor and also push it down with the fingers. So what we literally see is that the response of the interrogator, and that's running at 500 hertz. Next slide, please. this is, we are basically scanning a FPG and then applying the pressures upon one of the sensor, and then you can see that the channel is moving up and down a little bit. Okay, so based on what we've found so far, that we think that we have an extremely rugged in terms of electronics, mechanical, and optical system that we hope that to be able to incorporate in our customers' aerospace system